Hi, my name's Matt and I'd like to welcome you to this Zindiac training video on high velocity IT. In this video we'll be covering the second of the 5 high velocity IT objectives, that is fast development. Now in terms of the exam, the 5 objectives are worth 60% or 24 out of 40 marks on the exam paper, and fast development is worth 6 out of 40 or 15% of the exam. So this is an important video to follow and make sure we understand. You can see on my left the 5 objectives. We have valuable investment, which we've already covered, fast development, which we're about to cover, and also co-create value, assured conformance and resilient operations. So without further ado, let's move on. What is fast development? It's realizing new and improved digital products and services frequently, quickly and reliably. And obviously the reliable aspect of that is very important, that we don't rush and get things wrong, do too much too soon and deliver inferior products. So we need to make sure we're delivering reliably. As part of that, metrics to consider: mean time to recover service, mean time between failures. They're obviously different things. Ideally we'd have both. We'd have a long mean time between failure and a short mean time to recover the service. That would be ideal, but sometimes we may need to make a decision that perhaps mean time to recover service is more important than mean time between failures. So we can accept some failures, providing that we can recover from them very quickly. That can still give us a high availability figure. There's no intrinsic value in doing something quickly. It only has value if we get an outcome at the end of it. We get a sufficient outcome at the end. So the only time doing something fast has an intrinsic value is if you're in a race. Then clearly just being fast is valuable because you're likely to win the race. But in fast development, it's only in terms of delivering value to the business, to the customer, and enabling them to realise that value sooner because we've delivered faster. Measure cautiously, so we might measure the size of the application, change per unit of time. We may be using something like story points or some sort of points-based system. The important thing to recognise if you are using a points-based system is, so for me, when I'm creating these videos, fast development is one of the 5 objectives. Let's say it takes me a week to create that. When I come on to the next one, co-create value, I've got a benchmark. It's roughly the same size. So if it only takes me 4 days rather than 5 days, I've done the same amount of work, but more efficiently, more efficiently, I've delivered it quicker. But that's what you got to look at. It's the same number of points. However I do the point system, so I say fast development's 10 points, co-create value is 10 points. I delivered co-create value quicker, therefore I've improved my efficiency, and that's what you're looking at. You've got to measure the size of work, not how quickly you can deliver it. Minimize the deployment overhead. So when we are delivering fast, ideally, if we're delivering iteratively and incrementally, we deliver a little bit of work, a little bit of work, a little bit of work. Those bits of work can get delivered, and we'll come on to continual integration, continual delivery shortly later in the video. But it's important that the overhead of delivery is small. If the overhead of delivery is large, then we're unlikely to deliver every time to the end customer, every time the developers deliver. Yes, the developers deliver, but that's only a day of work and it's 5 days to overhead of deployment, then we're not going to deploy. We're going to wait until we've got lots to deploy and then deploying once, which isn't what we want. So we've got to minimize that deployment overhead. And an important point to note that relates to that is that the smaller the change, the smaller the risk of disruption, and that's shown in the very simple diagram I've put at the bottom of this slide to my left. So the smaller the change, the smaller the risk of disruption. So that's a big positive for making the changes smaller. We'll see now on the next slide a more complicated diagram that says the same thing. So if the size of change is small, it leads to higher frequency of changes. Higher frequency of changes lead to smaller changes, and we get into a virtuous loop. It also leads to a smaller backlog, which is what we want. So we're in the blue circles. That's a virtuous circle. That's where we want to be. If we go into bigger changes lead to lower quality. Lower quality leads to more bug fixes coming back onto the backlog, which can lead to higher, bigger changes, which again lead to lower quality, and we get into a negative loop. So we want to avoid that. And I have seen in the worst case scenarios, I've seen organisations where they get into that negative red loop and they end up with a backlog that is just bug fixes, and they have a sprint that is just bug fixes. So one of the things to look at is size of change. The other thing to look at in terms of quality is whether the developers are empowered to de-scope. So if they're not empowered to de-scope, the ability to de-scope, the authority to de-scope is very important to an efficient working backlog and delivery of change. So do look out for that as well. We're going to look at 7 techniques that we can use to achieve fast development, and they're listed on the slide there. I won't read them all out. We're going to cover them all in turn, starting with infrastructure as code. Infrastructure as code isn't actually particularly new. 30 years ago, when I was working for IBM using mainframes, we were using infrastructure as code. We'd have virtual machines created on the physical hardware, and that's fundamentally what infrastructure as code is. We've got the physical hardware, the processors, the memory, the storage, whether that's solid state or disk drives, the I/O, the physical device, and they generally become bigger, more like the mainframes. But on top of that, we run virtual machines, and that's the infrastructure as code. So we can create a virtual machine with virtual memory, virtual processors, virtual I/O, virtual storage, and we can do that very quickly. So we're maintaining a very stable physical infrastructure, but the virtual infrastructure can be very dynamic, and that's key to fast development. It helps reduce human error and quicker recovery and incident prevention. Helps with resilient operations, it says. Fewer repeatable manual operations equals reduced costs, which is good. And we can use, I've mentioned virtual, so there's virtual and hypervisor technology to do it. Idempotence. Idempotence is an important concept with infrastructure as a code, and what it's about is having the same result every time. So you can see the mathematical formula I've put there that's often used to explain it. So in mathematical terms, if we run a function on x, we get a result. If we then run the same function on the result of that, we get the same result we had before. We still get the same answer as we did if we just ran the function on x. How does that relate to infrastructure as code? It relates in this way. If we run a virtual machine on the physical hardware, we get a certain virtual machine. If we then run a virtual machine on that virtual machine, we get the same virtual machine. If we run a virtual machine on that virtual machine, we get the same virtual machine. So we can run a virtual machine on a virtual machine on a virtual machine on forever. We still end up with the same virtual machine that runs and works in the same way. There's no degradation, there's no differences. So from a developer's point of view, we don't know and we don't care. Are we running on a virtual machine or a physical piece of hardware? We don't know, we don't care. It's the same. And if it is a virtual machine, is it running on another virtual machine? We don't know, we don't care. It works in the same way. And there's a list of tools there, such as Docker is the one I'm particularly familiar with, but there are obviously many tools out there that help with this. And infrastructure as a service, platform as a service utilize this technology and these concepts. We'll see a table like this for each technique. In terms of the exam, the ones you need to know are the ones that are highlighted, and these tables are just the high impact versions, or the high impact parts of these tables. So in the actual manual, if you refer to the manual, there's more lines because there's ones with medium and low impact as well. So I won't read them all out, I'll just concentrate on the ones you need to know for the exam. So architecture management, verifying architectural decisions and comparing infrastructure solutions, deployment management, automating the deployment of infrastructure, ensuring a faster and more repeatable and reliable deployment of both infrastructure and applications, service validation and testing, designing and maintaining test cases to ensure that virtual infrastructure as code meets organizational requirements and policies. Software development and management, developing software architecture and code to leverage fast development, provisioning of virtual hardware infrastructure. The second technique, loosely coupled information system architecture. So the easiest way to think of this is Lego. If you think about Lego, we've lots of bricks and other shapes and so on. They are individual complete pieces, and they have a predefined way of fitting together. And that's what we're looking for with loosely coupled information system architecture, that we can build complete finished units, modules, and they have a defined input and output way of fitting together. That's what we're looking for. Relatively small independent components. And it overcomes many of the problems of tightly coupled or monolithic architectures, which are slow to change and need more resources that reduce the speed of change. One way of moving, if we have a monolithic system built with a monolithic architecture, one of the methods you can use, as well as refactoring, is what's known as application strangulation, which is a bit dramatic, but all it means is we leave the existing application as is, and then we build a loosely coupled application around it and slowly strangle it. So the idea is that the new application slowly takes over from the old application until there's no old application left. You do need to monitor closely to avoid compromising performance and reliability. So they are risks that we need to monitor and try and avoid. Associated techniques, microservices and containerization. Again, I won't read the definitions on the slide, they are similar. Microservice is really just a small independent service, again with a defined input and output that we can call. Containerization, very similar, but more just focus on the software than a running service. Benefits: facilitates faster development, which is obviously what we're talking about. Enables an evolutionary architecture, so rather than having to plan out the whole architecture in advance and try to anticipate every possible change that we might have to handle in the future, which we kind of can't possibly do, it enables to evolve over time. So as the world changes, as customer requirements change, as new technology becomes available to us, we can evolve the architecture to meet those changing customer requirements, to take advantage of that new technology that becomes available to us. So much more flexible, much more agile. It's more efficient, leads to less work being needed on redesigning and redeveloping a product or service. And redesign, redevelopment, rework is waste. In lean terms, in lean IT terms, rework is waste, and it's something we really want to try and avoid if we can. And one of the key ways of avoiding it is adopting a just-in-time methodology or a just-in-time mindset, that we don't do too much work too soon, because the earlier you do the work, the more you do some work and deliver it before it's required, the greater the risk that between you delivering it and it being required, that something will change and you'll have to do it again. And that's what we want to avoid, because if we're doing work again, that's waste and it'll slow us down. So in terms of high velocity IT, fast development, we want to avoid rework. It enables the switch from a team-based structure focused on components to a product or feature-based team structure. So rather than focusing on how, we're focusing on what. That's the key thing. So rather than how, focus on what we're doing. Again, the list of practices that are relevant, that have a high impact on loosely coupled information systems. So architecture management, designing loosely coupled service, technical and information architectures, business analysis, understanding customer needs and translating them into detailed requirements for each component of a loosely coupled service architecture, deployment management. The scope of deployments and deployment patterns is reduced with the decoupling of system architecture. This makes deployments easier to manage and replicate and strong candidates for automation. Software development and management, the detailed design, building, running and management of loosely coupled software components. Reviews. So the first type of review we're going to look at is retrospectives, and this is very popular in an agile environment, retrospectives. There's two types, in agile there's two types of reviews. So we may have a review and a retrospective. So in Scrum we have a sprint review and a sprint retrospective. The sprint review looks at what we've produced. The sprint retrospective looks at how we've produced it. Have we worked well as a team? What about our processes and procedures? Have they been efficient and effective? And whatever titles you give those two reviews, they are logically different things. So some people refer to them as the review of what we've produced as the customer view or the outside in view, because it's the customer outside our team looking in at what we've produced, whereas the retrospective is in inside out view. So it's the people in the team looking at how we've worked, but in relationship to what we've delivered to the customer. So obviously, when we're looking at have we worked effectively, it's have we worked effectively to deliver for the customer. So that's what a retrospective is doing. There's lots of techniques for retrospectives, things like mad, sad, glad. And generally what we need to make sure is that when we are doing a retrospective, it doesn't become a moan fest. So whether you use mad, sad, glad, so obviously the glad is the things that made me glad, this is what we did well. The sad is kind of, oh, I wish we'd done that. These are things we should do next time. And mad is the things we did that we shouldn't do ever again. And again, whatever titles you give those things, some people talk about a compliment sandwich where you say something good, something bad, something good. But generally, however you do it, you need to make sure people are coming up with positives as well as negatives. That's the thing. So whatever technique you do, make sure you have a balance between positives and negatives. Again, the practices for retrospective, software development and management, activities and techniques to review work periodically to understand how to improve. So again, in Scrum, you hold a retrospective at the end of every sprint. Your sprint's 1 month or less, commonly 2, 3 or 4 weeks. And that's a regular review, a periodic review. Blameless post-mortems. Post-mortems indicate something's gone wrong. So something bad has happened. We've had an incident, we've had a problem. But it's important that when we're reviewing it of what went wrong, that it's blameless, it's non-judgmental. We're not seeking to find who's responsible for this. That's not what we're interested in. What we're interested in is what went wrong, why it went wrong, how can we avoid it happening again. One organisation I work with in the transport sector, they have a way of doing this, and they say if something goes wrong and they have a post-mortem, they'll say, how did our governance fail? How did our governance fail? Not how did an individual fail, how did our governance fail? And I think that's a great way of looking at it, because what it's saying is an individual may have made a mistake, but individuals are human beings. They're going to make a mistake. We know that. We all make mistakes. The purpose of governance is to make sure individual mistakes don't impact the business. So if we're having a post-mortem, a mistake has been made that has impacted the business, so the governance has failed. We didn't have sufficient, we hadn't trained that person enough, or we hadn't given them the tools they needed, or we hadn't given them the support they needed, or we didn't have the checks and balances in place, or something, but the governance has failed, not the individual. Because we can't expect individuals, human beings, not to make mistakes. They will. We all do. And I think that's a good way of coming to it. And it's part of that blameless culture. Originated in healthcare, airline industries. And the reason is, if you have a blame culture, if you're looking for someone to blame, then when someone does something wrong, they'll try and hide it. They'll try and protect themselves. And then you don't find out why it went wrong, and we can't improve, and it'll keep happening. Other people will make the same mistake. Whereas, and obviously in healthcare and airline, if mistakes are made, people might die. That might not be the case in what you're doing. It might just be the company loses some money. But if we have a blameless culture, people say, I made a mistake, this happened. Oh, right, okay. How can we prevent it happening again? And that's what we want. So it's part of that safety culture. Well, when we talk about safety culture, it's people feeling safe, that psychological safety. So good behaviours include conduct as business as usual, not exception. So it's just a regular occurrence. We're all used to it. Focus on what, not who. And share results broadly and transparently to learn and foster trust. And again, the airline industry and healthcare industry both do that. So if there's a plane crash, the information from the black box and the information that the airline discovers from that crash, they will share with all other airlines worldwide, because they know that if there is a plane crash, people don't think, I won't fly with that particular airline. People just think, I won't fly. So they share it widely. And we want to certainly share widely within our organisation. Depending on your organisation, you may share more widely than that. Obviously, it depends whether you're competing or cooperating. So for reviews, post-mortems, practices that are relevant, deployment management, investigating successful and failed deployments of service components to identify opportunities to improve the success of future deployments. The next technique, continual business analysis. Now, in simple terms, this is lean startup. So what we want to avoid is paralysis by analysis. Yeah. So, let's analyze it. Oh, we're not really quite sure. So let's analyze some more. Oh, we're still not. We need a bit more information. Let's analyze some more. And we just analyze and then never deliver anything. Or we wait a long time before we deliver anything, and then we deliver it, and the customer still goes, not really quite what I wanted. Not quite. Now I've seen it. It's not really, not so much. So lean startup, it's very much deliver a minimum viable product as soon as you can. And actually, the more uncertainty there is, the less analysis you should do. So it's a bit counterintuitive. You might think, oh, if we're really uncertain, we need to do more analysis. No, if it's more uncertain, take a leap of faith, build a minimum viable product and deliver it to your customer. And how often have you spoken to a customer and said, customer, what would you like? And they, oh, I don't really know. I'll know it when I see it. Can you just show me something? So you build something, you show them, and then they can get feedback. And when I say build something, the minimum viable products, your first minimum viable product might be a drawing on a whiteboard. And I've certainly done that. You're not really sure what you want. Okay, let me draw something on this whiteboard. Now, what do you think of that? Oh, right, yeah. Well, maybe if you changed it in this way, oh, right, I can do that really quickly and easily on a whiteboard. Yeah, even with modern development environment software, you can create very quickly, but not as quickly as you can make changes on a whiteboard. Get some feedback there, then maybe move to the next stage, get something physical, maybe with some hard-coded data in, or bit smoke and mirrors, but a view, something they can play around with, and go through that incremental iterative development. The most valuable analysis is customer feedback, is genuine customer feedback from something you've delivered, and that's what this is all about, continual business analysis. So it never stops. We're always looking to shorten that feedback loop to get feedback from the customer and take action on it, come up with new ideas and improve the product. So not surprisingly, practices for which this is highly relevant. Business analysis, continually scanning customers' market conditions and the broader ecosystem to understand their impacts on the organisation's products and services. And software development and management, continually scanning customer market conditions and the broader ecosystem to understand their impacts on the organisation's software products and the prioritisation of ongoing software development work, and obviously prioritisation of what we do next, because we're delivering small incremental bits. So what's the next little bit we're going to deliver? What's the priority? And getting that right. So for instance, for me, I'm delivering high velocity IT next. So of all the ITIL specialists courses, I've prioritised high velocity IT because that was the most popular bit. Those videos were the most popular, most watched videos in our managing professional transition course. So they seem to be where the demand is from the market. But let me know, leave a comment. If you want me to do one of the others, leave a comment. If you want me to do that next, I'm kind of working through high velocity IT first. That's where I've prioritised the work. Continuous integration, continuous delivery, and continuous deployment. And we can see the definitions there. So continuous integration, an approach to integrating, building, and testing code within the software development environment. Continuous delivery, so that's, I won't read it all out, but it's the delivery of the software to enable it to be deployed. Continuous deployment is obviously deploying it to the live environment. So the development team can deliver the software, and typically operations, DevOps, the ops bit, deploy it to the live environment, and then we release it to the users. We may deploy and release in one go. Obviously, we talked about that in ITIL Foundation. So one of the main aims of continuous integration is to keep the master branch free of exceptions and errors. And really what we're trying to avoid, again, is I talked about with the analysis of doing lots of work and then giving it to the customer and the customer going, that's not what I want. This is similar in terms of the developers doing lots of development, testing, doing all the unit testing, but then when it comes to integration, doing a big bit of integration and going, oh no, that breaks the master branch, that breaks the existing code, it doesn't work anymore. We've done all this work, we're going to have to do it again, rework, yeah, red light, rework bad. That's going to cost more money, so we want to avoid that. So really what we do is do a little bit of development and pretty much integrated straight away. It's integrated and tested, so straight away we're finding out if there's an issue. Hopefully there isn't. We're trying to keep that master branch free, so we're constantly integrating. So it's not just testing our code, because other teams might be integrating as well. So it's testing that our code works with their code, that it all works together. Continuous delivery is focused on the process of building and testing new releases and promoting them to the production environment. So again, delivery, trying to deliver ready for deployment, relies on the concept of progressive deployment rings for a deployment model. So deployment rings, as a minimum, if you're doing deployment rings, you've got to have two. Yeah, the minimum would be two, which if you just had two, it'd probably be internal, external. So you would deploy internally. If that went okay, you'd deploy externally. Typically, you'll have more than two rings. You'll have several. But each ring, you are deploying to more people, to more users. So you're increasing the risk. But because you deliver to a small number of people first, you can test there and gain confidence that when you release the next ring, you've reduced the risk of it going wrong there. So it's just a way of mitigating risk. Another deployment model, which is similar, blue-green deployment, where the existing version is the blue production environment. We have a parallel version, the new version green, and we transfer some users onto the green environment, and if it works okay, we transfer some more users onto the green environment, and if it's still okay, and eventually we get everyone onto the green environment. So again, it's a way of reducing risk or managing risk. Practices for which continuous integration, continuous delivery are most relevant. Again, I won't read them all out, just the key ones for the exam. Deployment management, the systematic, automatic installation of specific versions or packages of software to a predetermined environment. Integration, user acceptance testing, production. Service validation and testing, developing automated test cases to support continual integration activities, and software development and management, use of continuous integration, continuous delivery techniques that are used for application software. Now, there are a number of types of software testing that we can use, and we've got the list on the next 3 slides to fit it all on. I'm not going to read all the details on the slides. You can read them for yourselves on the slides. When you if you purchase the course package, which includes the exam, you can't purchase the course without the exam. If you purchase it as a package from our website, then you get a copy of the slides and you can read the detail yourselves. Where this is particularly useful in terms of using it is just as a checklist, really, is testing the ideas. How are we going to test the ideas? How are we going to test the idea for this bit of software, for this service is a good idea? And we need a plan for how we're going to do that. And when I say a plan, literally you could just write these lists of tests up on a whiteboard and have your plan written next to them. It doesn't have to be onerous, but you do need to do it and say whether you're going to do them. So some of these you might say, well, we're not going to use that form of testing, but you'd have to then justify it. We're not going to test the artifacts because, so the artifacts, things like epics, user stories, acceptance criteria, how do we test those things that they're accurate, that the user stories meet the customer requirements and accurately reflect and communicate the customer requirements, and so on. Testing the user experience and user interface designs. And it is important, so when you're talking about user interfaces, that it's not just it works or it can work, or someone who built it can use it, or even a customer can use it, but it's a bit iffy for them. Is it a good experience? On one of the other videos, I've done a review of the Polestar 2, and it's just got a fabulously easy user interface. It's just the best user interface I've ever seen in a car. It's just so intuitive and so easy to use. My current car's a Mini, and it's just a nightmare. I've had it nearly 3 years now, and I'm still like, oh, I know it does this, but how does it do it? And oh, not that way, which menu and which button, and it's just a mess. So does it work? Yes, it works. Can I get it to work? Yes, I can. Is the user experience good? No, it's really poor. Other bits of the car are fine, but the user interface is dreadful in the Mini. Testing the architecture and the code designs. Testing the code, and when it says testing the code, that's, can I understand your code? Can you understand my code? Not the next one, which is testing the operational software. Yeah, so when we actually run the code, does it work? We need to test in different environments, but particularly if we're deploying in different environments. Are we deploying to iOS and Android? Have we got the same code stream? Are we using something like Flutter, or have we got two separate code streams? We've developed in Swift and Java, or whatever ways we're using, but we need to test in different environments. Testing the release pipelines, so how we release, and is that efficient and effective? And I talked about minimizing the delivery deployment overhead, so that would be part of that. Testing the system in production, and there's various techniques and strategies we can utilize to help us do that, and you can see some there. So canary releases, again, that's targeting a small number of users before we release to more. Feature toggles, so we can switch new features on and off. So switch it on if we've got a problem to switch that feature off. We don't have to take the whole system down. Blue-green deployments we talked about before, and automated rollback strategies. So feature toggles are a version of that. We're rolling back, we're switching something off, but do we need to roll back completely to an older version? And that's usually our ultimate fallback. It's not working quite right. Let's go back to the last good version that we know works. And testing the services in production as the final one on the list. Principles for continuous testing. Tests should be written at the lowest level possible, with the fewest external dependencies. Favour those tests. Write once, run anywhere, including the production system. So just because we've tested doesn't mean we can't test in production. Products should be designed for testability. So that's when we're planning and designing the product, how are we going to test it? And test code is product code. Only reliable tests survive. So what that means is we are testing the test, and if the test code fails, then we need to rewrite it. Testing infrastructure is a shared service. Test ownership follows product ownership. That makes sense. Fault injections and chaos engineering test service resilience. Yes, if you've heard terms like chaos monkey, that relates to this chaos engineering. So it's really saying for the service, if something goes wrong, will the service still work? And whether you fault injection, chaos engineering, basically what you're doing is breaking a bit deliberately. So you're breaking a product or a module, or switching off a server, or breaking a network connection to ensure that the service continues. To ensure that the service is resilient. And finally, unreliable tests should be eliminated. Kind of obvious, I think. Practices for which continuous testing is most relevant. Architecture management, designing and improving service technical and information architecture to leverage continuous integration and continuous delivery capabilities. Service validation and testing, unit integration and regression testing is conducted on an ongoing basis throughout the development lifecycle. This includes application unit testing, infrastructure service testing, functional, non-functional testing, canary releases, blue-green testing, and infrastructure security testing. Kanban, the final technique we're going to look at, Kanban is a lean method. I'm sure you've come across a Kanban board, and many organizations just use the Kanban board maybe as a tool within a Scrum development team, within sprints, to manage the flow. But there is more to it than that. So the main practices of Kanban are visualizing work. So obviously the Kanban board helps us do that. It's a visual tool. We can see where the work is. We can see who's doing the work. We can see how the work's progressing. And it helps with that transparency, which again is a pillar of Scrum. Transparency, very important in agile and fast development in high velocity IT. Limiting work in progress. If you haven't come across this before, it may seem counterintuitive, but by limiting work in progress, we can improve flow. And there's a number of reasons for that. One is, if we allow lots of work in progress, people can tend to kind of get a new piece of work and do 80% that's relatively easy. And then it gets a bit difficult, and it's like, oh, that's a bit difficult. I'll do this other thing that's relatively easy. And then it gets a bit difficult. I'll do this other thing that's relatively easy. It gets a bit different. And they keep doing 80% of everything. How are you getting on? Oh, yeah, I'm 80% there. Yeah, but unfortunately, you've done the easy 80% of everything and you haven't delivered anything. Nothing's done. So limiting work in progress helps people focus and get stuff done. So if you don't have completer finishers, or you struggle with completing and finishing work, limiting work in progress really helps with that. And it also avoids task switching. So task switching of just kind of, I've got lots of things to do, I'll do a bit of this, I'll do a bit of that, I'll do a bit of this, I'll do a bit of that. And it's not that I don't want to finish stuff, I'm just kind of got spinning lots of plates. And again, that limits flow. It doesn't help with throughput efficiency. Managing flow, and that's what we want. We want flow. They talk about flow like turning on a tap and new delivery just comes out, new code, new software, new services just come flowing out like a water out of a tap, and that's what we're aiming for. Making process policies explicit. So process policies, things like, how do we define what's ready? If something's ready, when can I pull work to myself to start building? How can I move from build to test, from test to ready for release, from release to done? Making all those policies explicit. Implementing feedback loops, so obviously from the customer, but also at each stage. So from the people responsible for deployment to the people feeding back to the people who test, from the people who test to the people who build, from the people who build to the people who analyse. And in an agile team, we have multi-skilled people who are doing all those things, but we need to feed back anyway. So if I'm testing, I might be writing some code and testing. I'm not testing my own code. I'm maybe testing your code. You're testing a different colleague's code, and so on. But we need to have those feedback loops. Improving collaboration. Again, we don't want that silo mentality. We don't want to end up with a situation where the coders think the testers are the enemy, and the testers think the coders are the enemy, or the deployment ops are the enemy. Or, we're all part of a big team. We're collaborating. We're working together for and in support of the ultimate goal. That's what we're looking for. And evolving experimentally is the Kaizen approach of everything can be made better. We will make everything better. We'll make things better a little bit at a time. We'll do it by trying different things, by experimenting. Sometimes we'll try to make something better, it'll make it worse, and then we'll go back to the way we did it before, but that's okay, because overall we'll have an improvement. And it's very much the opposite of, if it ain't broke, don't fix it. So if it ain't broke, don't fix it. We want that attitude out of our organisation. That's the enemy of fast development in high velocity IT, and just generally efficient and effective business and life for that matter. We've got an example of a Kanban board there. I'm not particularly going to talk through it. It's a slightly more complicated version with stages rather than simply to do, in progress, test, done. You can make them as complicated. If you go on the web and to your favourite search engine and type in Kanban board, you will be able to find even more complicated versions than that. My recommendation, if you're just starting with Kanban, is keep your Kanban board really simple at the start. So I just have ready, build, test, done, and once you get into it, if you want to, as part of your retrospectives, as part of your improvement, you can experiment with more complicated ones, and if they work for you, great, and obviously move towards them. But start simple. Start with the minimum viable product. Kanban cadences are a system of regular meetings that ensure effective communication. And this is very similar to Scrum again. So in Scrum, they define a set series of meetings with a maximum length. And the reason for that is to avoid really too many other meetings, avoid other meetings if possible. And the Kanban cadences are very much in line with that. So you can see the list. I won't read all the list, you can read it yourself again, the list of meetings, but we can schedule those in. People know when they are, so perhaps our strategy review is the first Monday of every month, and we know where it is and when it is. And I think the other thing with this is obviously the frequency is organisation specific, but it works, and it will work really well in the modern world, in the new normal, where maybe more people are working from home. So it's possible where we schedule these meetings, and maybe some of these meetings are video conferences. I wouldn't have them as teleconferences, partly because I hate teleconferences, quite frankly. I think video conferences, and hopefully most of us have got the technology now to do video conferences, but some of them could be physical meetings. So if you are in that situation where people are working at home, maybe 2, 3, 4 days a week, maybe as much as they want, we have some meetings in place where we say, right, we're all coming in every second Thursday or whatever it might be, and we're all going to meet physically, and maybe go out for a beer or afterwards, or a coffee, or whatever fits into your culture. But we'll have that socializing, because that is important. And yes, you can do it to a certain degree over video conference and other means, but it's not quite the same. So it is good to have those meetings set. The practices that are particularly applicable to Kanban, the one we need to know for the exam: software development and management, visualizing and improving the flow of new or changed software components into live environments. And as we've gone through those tables, the 5 practices I have picked out are architecture management, business analysis, deployment management, service validation and testing, software development and management. And the reason for doing that, of course, is because they're the ones you need to know for the exam. So in simple terms, all the stuff we've just covered, I said fast development's worth 6 marks in the exam. So the stuff we've covered so far is worth 1 mark. And we've been going a while, but we've got to cover the syllabus, so that's worth 1 mark. And then these 5 practices are worth 5 marks, so you can expect 1 question on each of these 5 practices. That would be a reasonable expectation. So we're going to cover those now. Architecture management. The purpose of architecture management practice is to explain the different elements that form an organisation. This practice explains how the elements interrelate to enable the organisation to effectively achieve its current and future objectives. It provides the principles, standards and tools that enable an organisation to manage complex change in a structured and agile way. And you can see on the diagram to my left, figure 2.1, the architecture levels related to the 4 dimensions of service management. And really what it's saying is, it's a checklist of the architecture levels, from infrastructure, so the actual physical components, IT systems, products and services, business and wider environment, and all 4 dimensions of service management are applicable across all those architecture levels. In terms of success factors, as I did before, I've split them into definition and delivery. So the book doesn't do that, but I think it just makes sense, and it's an easy way to kind of think about it. So there's defining the architecture, or planning the architecture if you prefer plan. Proper planning prevents poor performance. If you're not planning to succeed, you're planning to fail. That's the definition bit. So we've got to make sure we do that. That's key to the success. And then obviously you've got to execute the plan. That's the delivery. So however you want to categorize it, I've categorized them as definition and delivery. So the success factor for definition: ensuring that the organization's strategy is supported with a target architecture. Architects need to understand the following: the organization's strategy and its current performance, the current architecture benefits and constraints, any pain points, any problems, issues we've got with that, the organization's portfolio and ongoing developments, environmental factors and trends, technology trends, risks and opportunities. I talked about that before, what new tools and techniques and technologies are available to us, and anything else that's relevant. Characteristics of an effective architecture, and again, I won't read scalability, cost effectiveness. I won't read all those out, but they're obviously targets. Those characteristics we target to deliver those, and depending on our organisation, some might be more or less important to us, and obviously we need to understand how that is. And then delivery of the architecture we've defined, ensuring that the organisation's architecture is continually evolving to the target state. And again, we're using that word evolve. So it's not we've got the old architecture, we've got the new architecture, we're throwing it away and doing it in one big leap. That doesn't follow the ITIL principles. So we're evolving to the target state. We're gradually moving towards it. We can have a roadmap that says, this is where we expect to be in a month's time, 3 months' time, 6 months' time, 5 years' time, 10 years' time. Obviously, the further into the future on the roadmap, the less certain it is. So we want to define it at a higher level. Again, if we don't want to be changing that roadmap all the time, because if you change it all the time, we've defined it at too low a level. Yeah, so there's stuff close to you can define at a reasonably low level. 5-year, 10-year plan needs to be really nice and high. If appropriate, we can manage it as a collection of programs or projects, or if they're just really small changes, it might just be a collection of iteratives delivered by business as usual. As it says, the transition is not a revolution, it's an evolution. Some legacy solutions may coexist with newer solutions for a significant time before we can switch them off or migrate them. And changes are always subject to portfolio decisions and careful prioritization. So the changes, we have a roadmap, but external factors can affect that. So it may be that other things take a higher priority and then we have to flex it. So again, try and have some flexibility in your roadmap. The architecture management practice is used to define the target architecture and to maintain the agreed direction and pace of the architectural evolution. And ensure that changes made to the organisation's resources, products and services support the architecture's evolution. So in terms of resources, including people, that we're hiring people with the right skills that are going to support the future architecture, not just the existing architecture, and the same with products and services. Have that future view. Business analysis. The purpose is to analyse a part or the entirety of a business, define its needs and recommend solutions to address these needs and or solve a business problem. The solutions must facilitate value creation for the stakeholders. It enables an organisation to communicate its needs in a meaningful way and express the rationale for change. This practice enables an organisation to design and describe solutions that enable value creation in alignment with the organisation's objectives. So very much in line with the service value system and focusing on value for the customer. And that's our vision, and how do we support that? What are the objectives, and how are we going to deliver to those objectives? So everything we do is focused on delivering value to the customers or the business. So again, it's that voice of the customer, voice of the business. If the customer doesn't want us to do it, if the business doesn't need us to do it, it's ways to get rid of it. But otherwise, the whole organisation's aligned to that purpose. As organisations evolve through digital transformation, digital solutions are progressively integrated into business value streams. Yeah, so rather than, again, the kind of the further back you go in time, we maybe had the business and technology and business analysis sat between them and kind of interpreted the business requirements in a way that the technology team, the IT team could understand, and the IT would deliver it, and then the business analyst would also help explain why technology had delivered what they delivered to the business. But it was very much that interface role. Whereas now, with integrated digital teams, where we have a team with people from the business and technology, and they're all working together in one collaborative team, business analysis sits within that team. It's not an interface between two teams. Definition, success factors. So in definition, establishing and continually improving an organisation-wide approach to business analysis to ensure that it's conducted in a consistent and effective manner. So how do we do business analysis? So models that support that, gathering information from stakeholders, providing information to stakeholders, identifying and translating business needs into well-articulated requirements, and assessing the actual solution's performance of value and recommending further improvements. And obviously that's important, that we don't just assume that we have achieved or realised the value we thought we would. We've got to assess that and use that for improvement. Delivery, ensuring that current and future needs of the organisation and its customers are understood, analysed and supported with timely, efficient and effective solution proposals. And clearly we can make a proposal and it can be rejected because it doesn't meet requirements, or it's too costly, or sometimes there's just something else more important. So we do kind of, each one needs some form of mini business case, but exactly what it needs will obviously be will be defined when we define how we're going to do business analysis. Stakeholders require assurance that their needs have been understood. And again, the lean startup helps with that. I think this is what you mean. Okay, I'll play it back to you, but also I'll deliver something small and quick and give you the opportunity to feed back to me. Maybe you haven't understood your requirements as much as me. So yeah, that happens as well. Guidance on the available options and associated benefits, costs and risks. All right, they're your requirements. Well, we could meet your requirements. You could have this or this or this. And do be careful with that. If you offer someone 3 options, psychologically it's very difficult not to pick the middle option. And there's lots of examples of that. So you might want to offer an even number so they can't pick. Again, with surveys, you see that now a lot. Rather than offering you maybe 5 answers, they just offer you 4. So you've got to get off the fence. You've got to make a decision. So think about that for the guidance. Deployment management. The purpose of deployment management is to move new or changed hardware, software, documentation, processes, or any other component to live environments. It may also be involved in deploying components to other environments. And you can see there, figure 5.26, release management in an Agile DevOps environment from ITIL Foundation. So that's showing deployment and release separately. Deployment and release can be done together. Deployment is where we deploy into the live environment. Release is where we release it to users. So they can be one, we can package them up and decide to do them together, deploy and release, but we may separate them. So it's just important to remember that. I'm sure you remember that from Foundation. Success factors, establishing and maintaining effective approaches to the deployment of services and service components across the organisation, deployment models based on several factors, and they're listed there. Again, I won't read that big long list out. You can read that out for yourself, but obviously we need to consider all those things. Delivery, ensuring the effective deployment of services and service components in the context of the organisation's value streams. Requires orchestrating resources in all 4 dimensions, dependent on and impacted by the availability of relevant resources, skills, technology, tools and infrastructure. Yeah, clearly if we haven't got the relevant resources available, then we're going to be negatively impacted. Technology automation can improve consistency, agility and efficiency, and certainly that is something within DevOps that they're looking to improve upon. So at some point in the delivery of a product or service, there is the last point of human interaction. So a human being clicks a mouse or hits return or touches a touchscreen, and then the software and hardware takes over and does the rest. So there's always that last point of human interaction. And what DevOps is trying to do is move that last point as far back as possible, i.e. to automate as much as possible. And that's something to think about. And obviously that really supports high velocity IT. Crucial that service component integrity is maintained. And we talked about, components like Lego bricks, so we need the integrity of the component, that we don't have to go back and change them because another component's changed. So once the component is finished, it is finished, and we maintain that integrity. And that what gets deployed is what's tested. So we develop some software, we test it, it gets signed off by the customer, the user. We need to make sure that what was tested and signed off is actually what gets delivered. That nobody, I'll just make a change. No. Yeah, so we have to make sure we have processes and procedures in place to make sure that what gets deployed is what was tested. Requires effective alignment of the deployment to change and release requirements in schedule and cost. Service validation and testing. The purpose of service validation and testing is to ensure that new or changed products and services meet defined requirements. The definition of service value is based on input from customers' business objectives and regulatory requirements, and is documented as part of the design and transition value chain activity. These inputs are used to establish measurable quality and performance indicators that support the definition of assurance criteria and testing requirements. Considerations when defining scope level of validation testing. Agreed requirements that a product or service must meet, and the impact and likelihood of deviations from the agreed requirements. And those of you who do lots of risk management will immediately see impact and likelihood as being to do with risk. Yeah, so if there's a deviation, that's uncertainty as to what could happen and what's the likelihood of that and what would the impact be. So that's very much aligned with risk management. So service validation is performed in the earlier stages of product and service lifecycle. It focuses on confirming the proposed design meets agreed requirements and on establishing acceptance criteria for the next stages. Follows the structure of service requirements and usually covers utility and warranty, experience, manageability and compliance. Ensures the definition, verification and documentation of service acceptance criteria. That's really important that we understand what the criteria are for service acceptance. We don't want to get to the end and deliver something that we think works and then have the customer say, no, I'm not accepting it. Well, why not? Oh, I'm just not. Yeah, you can't do that. So you've got to know what the acceptance criteria are. So if we meet the acceptance criteria, they've kind of got to accept it. Informs the scope and focus of testing activities, which brings us nicely on to testing. which is based on the criteria identified through service validation. So passing the baton. A test strategy defines an overall approach to testing, and we covered that previously. Effectiveness is based on close collaboration between testers, developers, and operations teams, enhanced tooling and automation approaches, and expanding beyond technical aspects to include user experience and perception. I talked about that before. So just because something works doesn't mean it's acceptable. And we do need to think about user experience and perception. And users are more likely to use something that they enjoy using, or that at least find easy and intuitive to use. Success factors, again, definition, defining and agreeing an approach to the validation and testing of the organisation's products, services and components in line with the organisation's requirements for speed and quality of service changes. Obviously, different organisations have different requirements. Some might require more speed, some might require more quality, might be more important. We've just got to get the balance right. Testing phases include unit testing, integration testing, system and acceptance or user acceptance testing. And that's the formal test phase. So that's the phase at which probably we're going to ask a user to sign a piece of paper or in some other way record their formal acceptance. And then we've got test types. So we've got functional, testing what the system does, and non-functional, so things like performance, load, stress, security, usability. And regression testing, so new developments, progression, and bug fixes can introduce unexpected behaviour. Regression testing aims to verify that the system still functions following the change. Yeah, so we're not just testing the new bit or the bug fix, we're testing the whole thing to make sure we haven't broken anything. The new thing hasn't broken something that had previously been working. Delivery success factors, ensuring that new and changed components, products and services meet agreed criteria. So we've obviously agreed the criteria previously, are we meeting them? And the things to look for, the test organisation. I've put an exclamation mark on the independent of those that develop the system. I'm not sure if this kind of missed Axelos testing, because it's a bit it's not agile. That doesn't agile. We talk about multi-skilled people who do development and testing. You know, analysis, development, testing, delivery. They can do everything. We have one job title, developer. But they're talking about having a test organisation independent. So certainly it is true that you can't mark your own homework. You can't mark your own exam test. So if I build some code, I need someone else to test it. If you write some code, I or someone else needs to test it. So if that's what they meant, fine. But it's not quite what they wrote in the exam. So do be careful about that. For the duration of the exam, the book's right, and the book says test organisation independent of those that develop the system. Testing, planning and control. Testing should be involved in sprint planning. Test analysis and design. Each release to testing includes a payload that can be divided into payload elements which reports on a discrete test pack. So from an exam point of view, I would remember payload element as a phrase that might come up in the exam possibly. In simple terms, all we're doing is we're just breaking it down. It's the old boulders, rocks, pebbles, sand. We're taking something big, which is a release, and we're breaking it down into payload elements that can be broken down further. So that's all we're doing there. Phases and cycles. Test highest risk, most complex or newest first. That's where the greatest risk is. Test preparation, execution. The defect manager, again, you might need to remember that for the exam. Defect manager ensures defects are prioritised and resolved quickly. Again, in a self-organising team, Do we have a role that's defects manager, but suddenly again in the book, in the guidance, it's got that role in there, so it might come up in the exam. Evaluating exit criteria and reporting, i.e. what allows us to say or enables us to say testing is finished. We have sufficiently tested this thing, this product, this service, this upgrade, so we can exit and we can close. And how do we close? What is the formal or not method of closure? And finally, the final practice, software development and management, which has the purpose to ensure that applications meet internal and external stakeholder needs in terms of functionality, reliability, maintainability, compliance, and auditability. All the abilities. It's increasingly, software engineering is increasingly important for infrastructure and platform management. So we're talking about infrastructure as a code. So obviously, infrastructure codes, we're creating virtual infrastructure using code. So software development and management supports that. And bigger shares of an application's total cost of ownership shifts to development. So constant change is integral and not referred to as maintenance. So rather than having, as we used to say, maybe 20% was development and then 8% as maintenance, if we've got constant change and it's continually evolving and improving, so it's not just fixing bugs, it's not just little tweaks, but we're really building, then it becomes more viewed as development rather than maintenance. In some way, it doesn't really matter what you call it, it's just a word. As long as we all understand what we mean. And sometimes using different words helps with a shift in attitude or behaviour or mindset. So we've got some definitions. Software, I think you probably know all these, but software, a set of instructions that tell the physical components of a computer how to work. I won't bother reading the rest, I think you know that. Software development, the development of the software. Again, you can read the exact definition if you need to. Maintenance, the modification of the application as part of development for both corrective and enhancement purposes. And we can do corrective, preventative, adaptive, and perfective. So corrective, correcting the default, preventing, trying to prevent defects. Adaptive, adapting the application to work with changed infrastructure. And perfective, enhancing the functionality, obviously trying to get to the ideal. Software quality. So it's important that we or you define what your organisation or your team means by software quality. So the things you might look at, functional suitability, does it do what the customer needs it to do? Does it perform efficiently? Is it compatible with other software, other systems? Is it usable? Is it reliable? Does it always work in the same way, and does it work continuously? Is it secure? Obviously a major factor now. Is it easily maintainable? Can we change it easily, or is that difficult? And is it portable? Quality in use, effectiveness, efficiency, satisfaction, customer satisfaction, freedom from risk, and context coverage. So we can think about all those things. Technical debt. The total rework backlog accumulated by choosing workarounds instead of system solutions that would take longer. And for those of you old enough to remember, the ultimate example of technical debt was the Y2K or the Millennium Bug, where prior to the year 2000, many software developers had hard-coded the year 2000 into their systems. That basically meant come the 1st of January year 2000 they wouldn't work, and they did that because it was cheaper, it was quicker, it was easier, but ultimately it led to a great backlog of change that many organisations just decided not to do and just replaced. It was great for Oracle and SAP. They got lots of business by selling new solutions that were Y2K compliant, but that was a big issue. We want to avoid that. We want to avoid technical debt. The software development lifecycle model. The sequence in which the stages of the software development lifecycle are executed. The major stages are establish requirements, design, code, test, run, use the application. Now, there's different models that we can use with that. So the waterfall model says you do each of those stages in turn. So you do establish all requirements, do all the design, do all the code, do all the test, and then release it all in one go. And if you're absolutely sure that what you will need at the end is what you need at the beginning, your requirements are not going to change, then that's a perfectly valid way of delivering a solution. But if there is a degree of certainty, if there's a degree of uncertainty that you think, well, things might change, then that's where the incremental model becomes more popular. And the more uncertainty there is, the more that model works. So incremental is we do a bit of the requirements and then design that bit and code it and test it and hopefully release, and then a bit more requirements, and we can do it in parallel. So you don't kind of go all the way through and all the way through and all the way through. You're establishing requirements, you're starting to design against those requirements while you establish more requirements, and you're starting to code while you do some more design and establish more requirements, and you're starting to test while you do more coding and so on. So it's very much running in parallel. And the iterative or evolutionary model is really a version of the incremental model where we're less sure. So in incremental model, you can kind of know what all your requirements are, but just do it incrementally. Iterative or evolutionary is really saying maximum degree of uncertainty. We really don't know what we're doing, or we don't know what we need to do. We don't know what the end goal is quite so much. So we definitely need to deliver iteratively and incrementally and evolve over time, evolve the solution over time. Scrum is an iterative time box approach to product delivery that is described as a framework within which people can address complex adaptive problems while productively and creatively delivering products of the highest possible value. A bit in quotes is from the Scrum Guide. I'd just pick out it's addressing complex adaptive problems. If your problem isn't complex, you don't need a framework to solve it. Just solve it. And the adaptive bit is that it's changing. So what the problem is today isn't what the problem is tomorrow. So it's that complex system. We're living in a complex system. Things are changing, so we need to adapt our solution to it. We want to be productive. And Scrum, the culture in Scrum is important. We need to have focused, committed, skilled, knowledgeable people for it to work. And creatively, going back to that experimenting and doing things in a different way and trying things, and we can always make things better. Excuse me. We need to have a clear definition of done. So what do we mean by done? And in Scrum, they talk about improving the definition of done. So refining the definition of done so what we produce becomes better. So what's done today, the requirements for being done today, the requirements for being done tomorrow, the thing that's done today wouldn't be done tomorrow because our definitions change, and it requires a higher quality basically product in order for it to be done. So in terms of success factors for software development and management, definition, agree and improve an organisation's approach to development and management of software. Different approaches require different combinations of resources. And small Relatively independent multifunctional product-based development maintenance teams in which a product owner manages the priority of the work to be done, so that's very much aligned with Scrum. Platform-based teams that support the development maintenance teams with the provision of required infrastructure for development, maintenance and production. So that's what do we develop on. Version control tooling that tracks all production artifacts, so we know what version's live and what the latest version is, and that the version we release is the version that's been tested. I talked about that before. Automated processes for continuously integrating and delivering and deploying software, and obviously that's key to fast development in high velocity IT. And finally, delivery success factors ensure that software continually meets organizations' requirements and quality criteria throughout its life cycle. The most important components are understanding the source code, understanding the requirements in the context, ensuring that non-functional requirements are included in definition of done, creating tests before coding, so that's tests first, effective version control, approaching the task of coding with a full appreciation of its tremendous difficulty, and respecting the intrinsic limitations of the human mind. Yeah, I don't know who put that in, a coder, I guess. But we do need to recognise that coding can be difficult, and just because we delivered 50 story points last sprint doesn't mean we're going to deliver 50 story points this sprint. We might just come against something that's just a bit more difficult and we might deliver less. And as I said, it's really important that the developers can de-scope and aren't under undue pressure to deliver everything on the sprint backlog in the sprint, because if they do that, quality goes down and then you end up with lots of bugs on your backlog, and you don't want that. Adhering to coding conventions, peer review and fast feedback from testing, so shortening that feedback loop, using automated testing and taking remedial action quickly. So there we have it. We have covered the second of the second of the high velocity IT objectives, which is fast development. We've just got 3 more to go, and then we will have covered the high velocity IT syllabus. I hope you've enjoyed this video. I am doing the objectives in one, which does make the videos a little bit longer. So do leave me a comment. If you think they're too long, you'd prefer me to split them up a bit, I can obviously do that. Let me know. But if you enjoy it, give me a thumbs up. If you haven't subscribed, please subscribe. Please subscribe to the channel. It helps support making these videos and making them available to you for free to preview. Remember, if you want to purchase the course, you can only purchase the course with the exam. Obviously, the full course includes the sample exams and the syllabus and a PDF of the course slides for you to read at your leisure. You can only purchase that with the exam as a package from our website. So until you see me again, have a great day.